Let's enjoy one more initial value question here, and then that should, in essence, wrap up basically assignment number 24. So here we go again. We're told that the derivative of a function is equal to this, and then we're given this information, and the question is, what's the function that satisfies both of these? And again, functions are also known as y. I look at it kind of like it's algebra. I'm solving for y. So the first idea would be to clear the fraction, dx. All right, and this changes this into dy. And then we have 3x cubed plus, let's do something here. Let's change that 2 over x squared into 2x to the negative 2 power. All right, dx. I didn't think ahead to make sure I had a good marker for this question. I hope there's a good one laying around here. So I'm going to try to get that ready to go. All right, now very similar to what we saw earlier. The way we transfer a dy, which is effectively, symbol for a differential or a derivative, is to integrate. So if we integrate both sides of this, the integral of y, or the integral of 1, there's a 1 there, right? The integral of 1 dy is y. And again, I could put a plus c here, but I'm going to consolidate the two constants onto the right-hand side. All right, and then the antiderivative of 3x cubed would be 3x to the 4th over 4. I want to remind you again of our new friend, the power rule, right? Add 1 and then divide, which is the exact opposite of multiply, subtract 1. Plus 2x add 1, that would be negative 1, over negative 1. And then let's consolidate the two constants, the plus c over here and the plus c over there, into one constant, and just call it, instead of having c1, c2, we'll just call it c. That's the combination of the two constants. So it looks to me like if we clean this up, let's clean this one up a little bit. So, let's see, I'm trying to think where to do that. I guess there's room here. So that would be 3x to the 4th over 4. I'm going to clean this up a little bit. First of all, there's a plus and a negative, minus, and that's going to be 2 over x. Take that underneath, consolidate a few things, plus a constant. Okay, so there would be our, what I like to call base curve for this situation. If the c was a 0, it would just be this base curve here. And now they're saying, what does the c have to be for it to satisfy this right here? So, let me transfer this up here. Y equals 3x to the 4th over 4 minus 2 over x plus c. And now they're saying, okay, of all those curves, for all the different values of c, what does c have to be for it to satisfy this? And this is basically saying when x gets plugged in with a 2, when x is 2, y is 17. All right? So basically, if we impose that information onto the question, put 2 in for x, put 17 in for y, we'll be able to use algebra to solve for c. So, put 17 in for y, put 2 in for x, and solve. And it's mostly arithmetic here now, all right? 2 to the 4th power is 16. 16 divided by, this is arithmetic, I'm freaking out here, 16 to 4, that's 12, I hope, minus 1 plus c, 17 equals 11 plus c, subtract over the 11, c would have to equal 6. All right, so it looks to me like, and we're almost done. Now what we do is we go put this back up here to get our final answer, or, I don't know, over here, and I'm going to write the final answer. Y equals 3x to the 4th over 4 minus 2 over x plus 6. That is the function, the y. I could put f of x. I don't care. But that function has a derivative of this, and it also hits that ordered pair there. So that would be the answer to that one. And I believe that should take care of assignment number 24 for us. And so good luck with that, and we'll get that out to you. And you'll have that one done, and we're one step closer. So let's go integrals.